you can see the three components, logical digital components we have studied in previous video. We have the OR, the AND, and the NOT gate. And here you can see the truth tables of the three gates. Just a brief note about the NOT gate. You can see that the truth table has just 2 rows. It's different from the other ones because here we have 4 rows and here 2 we have 4 rows. Why this one has just 2 rows? Because there is just one input, A, and so we have just 2 possible values, 2 possible conditions, 2 possible states for this input. And this is the reason why, in this case, we have a smaller truth table, just 2 rows, 2 cases. And now I'm going to build a more complicated circuit, a logical circuit, combining all 3 different basic gates. And first of all, I go to File and New, so to open a new board, a new space to build a new circuit. And I take an AND gate and another one here and an OR. And I make this connection between the 2 AND and the OR. And I put an output pin here, and I give it a name X as usual, East, sorry. Then I have an input pin here and connect to the first gate, and I place a NOT on the second input of the second AND, sorry, okay. And I place another NOT on the first input of the third AND, a second input pin, and finally here. So let me drag this one a bit on the right so we can see it. Okay. So here you have a logic or digital circuit, and this circuit contains 1, 2, 3, 4, 5 different gates connected between each other, as you can see. And we can try how this circuit works. It's easy. We have just to change the value of input and see what happens in output. But first of all, I give a name, as usual, to this 2 input so we can distinguish between them. Here it is. So one more thing, you see this these dots here and here, and these dots are important because they the meaning is that here there is a connection between this wire and this one. You see, in this case, for example, there is no dot, and that means that there is no connection between this wire and this one. So this wire is going over this wire. There is no electrical connection. And so this one is an electrical connection, and this one is not an electrical connection. Maybe I made a mistake here. Yeah, you see, because I saw a little dot here. So I'm going to repair the circuit. Okay, now it's okay. And now I'm going to try the operation of this circuit. When there is a 0 and 0 in input, I have 0 in output. When I put 0 1 in input, I got 1 in the output, and vice versa. But when 2 inputs are both at 1 values, you see the output is 0. This is quite different from the OR gate, because in the OR gate, if I have 2 1 in inputs, I have also a 1 in output. In this case, in this circuit, with 2 1, I have 0. This particular circuit is called exclusive OR. An exclusive OR is a circuit in which the output is 1 when one or of the 2 inputs is 1, is true, but not both at the same time. So it is 1 in this case, it is 1 in this case, but not in this case. So let's do the truth table. I'm going to copy this one and paste it in the next circuit. And the name is exclusive OR, or I can, for briefly, write XOR. And the truth table is 0, 0, 0, 0, 1, 1, 1, 0, 1, but 1, 1 is 0. So, before concluding, I'm going to show you a little trick to simplify this circuit. Instead of having this NOT gate here, I can remove it. And going into the property window of the AND gate, you see at the bottom I have negate top and negate bottom here. I don't see if you can see it, okay. And I choose negate bottom yes. You see, now I have a little circle on the second input of the AND gate, and this circle, it means that here there is a negation, or in other words, it is like as if here there was a NOT gate. It's the same identical behavior, and so I can also delete this or not here, and in the same way choose negate bottom. Top is this one and bottom is this one. So negate bottom, yes, and you can see our circuit works exactly in the same way as before. And that's all for now. Bye.